Alright, today we're going to take a quiz on binomial distributions. It is a quiz on what you don't know about binomial distributions. You're just going to guess on a 10-question quiz. You're going to guess the answers. So this is going to be notes. I'm not going to have an assignment for you to turn in. So on paper, in your notes, number your paper 1 to 10, and then answer questions 1 through 10. Your choices are A, B, C, and D. Can you do it in 1 minute? 10-question quiz in a minute. You're guessing because you don't know anything about binomial distributions unless you looked it up. So you're going to guess. And we're going to see how good you are at guessing. So number 1, A, B, C, or D. Just guess. I don't know. Question 2, A, B, C, or D. I'm going to close my door and let you finish the quiz. Again, if you just joined us, you're numbering your paper 1 through 10. You're taking a quiz. You're guessing A, B, C, or D. Let me close my door real fast. Alright, now you're going to grade your quiz. You're going to give a self-grade, see how you did on your quiz. So grade yourself, just be honest. We're going to calculate the probability of getting each question right. So we're going to focus on this idea for most of the day today. So here's the answers. And you're going to grade yourself. And how many questions you got right. I don't think anybody got a 10 out of 10. Two out of 10, 3 out of 10. Okay, you're entering in the chat box. Awesome. 2, 1, 5. Ooh, somebody got a 5. Talia. 0. That happens. There's a chance of getting 0 right. Most of them are 2s and 3s. There's a 0. So not very many 1s, mostly 2s and 3s. We can calculate. I can calculate these probabilities. So this is a simulation of taking a 10-question quiz and how many questions you get right. So I'm going to count how many 2s there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. Got 9 2s. And how many 1s? We got 1, 2, 3, 4, 4 ones, 2 zeros, 3. We got 1, 2, 3, 4, 5, 6. 6 3s. We didn't get any 4s. Let me double check for 4s. We got 1 5. Okay, everyone's jealous of the 5. Everybody's jealous of the 5, but a 5 out of 10 is still a 50%. So if you just guessed, like a lot of people, a lot of students especially, they say, I don't know anything. Well, if you don't know anything, then I just proved on a 10-question multiple choice quiz. For example, your chapter 6 quiz or your chapter 6 test is going to be 10 questions multiple choice. If you don't know anything, most likely event to occur is get a 2 out of 10. Okay, if you don't know anything, really, you're going to get 2 out of 10. So I'm going to write down the numbers. So it's possible to get 0 questions right. And we had 3 zeros and 4 ones. And 2 questions right, we had 9, 6, 0, and 1. And all these 6, 7, 8, 9, and 10 questions right, we got zeros. Nice. Alright. So there's your most likely is to get a 2 or a 3. And that's simulated probability. And that holds true because the theoretical probabilities are the same. So we can calculate the theoretical probability for getting 0 questions right, 1 question right, 2, 3, and 4. So what's going to happen? Simulation-wise, it's out of 23, so 9 out of 23. The most likely event, 39% of our students got 2 questions right. Okay, that's most likely. What is the average? What would the average grade be, theoretically? And that's called the mean of this is called a binomial distribution. Okay, in a binomial distribution, let's see here. In a binomial distribution, each observation falls into one of 2 categories, success or failure. A success was getting a question right. And I'm following along right through the book. This is the beginning of 6.3. Gosh, we're over halfway done with the book already. If something follows a binomial distribution, this green box on page 383. So page 383 has the conditions for a binomial distribution. Okay, we have discrete probability distributions like 6.1. That's a unique distribution. We talked about the number of pets you own. We talked about the number of items you can buy in the store. Each observation falls into two categories, success or failure, and is fixed. So in our problem, we had success, so probability of success. I don't think I'm going to have room here. Probability of success means get a question right. Probability of the question is right. That's a success. The probability of failure was getting a question wrong. Failure is getting a question wrong. N is fixed. N equals 10. There are 10 questions. We'll learn today about a distribution where N is not fixed. N is changing. n observations are independent, knowing the result of one observation will not tell you about anything in other observations. Okay, so we have independence. And sometimes for independence, you're going to check a condition, and I'll get to that later. So the condition check is 10 times the sample size. The probability of success is fixed. Probability equals 0.25 for each question. So the probability of guessing correctly is 0.25. So we have all these conditions are met for this example. Therefore, it is a probability distribution. Again, page 383. And they use the acronym BINS, B-I-N-S, to check the conditions. B stands for binary, success and failure. I stands for independent. N stands for a number, N is fixed. S stands for success, probability of success. So BINS. I think it's a pretty cool little acronym there. I can talk quietly now. I was yelling there. Alright. So we can calculate all these probabilities. Using the tree diagram, calculate the probability x equals 1, getting one question right. First of all, I'm going to calculate the probability of getting no questions right. So I'm going to calculate all of these probabilities. Probability of getting none of them right is 0.75 raised to the 10th power. In a tree diagram, I don't have room for my tree diagram. Let me do it over here. So it makes the tree branches for a tree diagram. So the probability of getting a question right is 0.25. Probability of getting a question wrong is 0.75. This is right and wrong. You get the question right. This is in 2 questions, wrong. So to get 2 questions right, that's 0.25 times 0.25. The other question I asked, find the probability of getting that one question right. That would be 0.25 times 0.75. Or 0.75 times 0.25 in 2 questions. So I'm going to make 10 branches. Okay, that's going to take forever. I'm not actually going to go through and make 10 branches. I want to show that if we got a question wrong, if we get 2 questions wrong, 0.75 times 0.75. What if we get 3 questions wrong? 0.75 times 0.75. I want to know what's the probability of getting all 10 of them wrong. You got a 0. Okay, we got a couple people that got 0s. That's possible. That could happen. Got them all wrong. 0.75 times 0.75 times 0.75 times 0.75 times 0.75. Okay, how many times are we going to do this? 10 times. So the probability of getting 10 wrong equals 0.25 or 0.75 raised to the 10th power. .25 raised to the 10th power is 10 right. 0.75 raised to the 10th power is 10 wrong. 0.056. So I just mentioned, find the probability of getting 10 of them right. Equals 0.75 or 0.25 raised to the 10th power. 9.536 e negative 7. Okay, the answer is not 9.5. E negative 7, that means 6 zeros. Probability of getting them right. All of them right. What are the chances of that happening? That's really small. Okay, so the branch that we would go down is this branch right here. 3 right. 4 right. 5 right. 6 right. I don't have room for getting 10 of them right. Keeps going and going and going. Okay. But to calculate theoretical probability is really small. Okay, this is called a binomial probability distribution. Now the formula gets a little crazy because what's probability of getting one question right? So here's one question right. I got the first one right and the next 9 wrong. Or I can get the first one right, or the first one wrong, second one right, the rest wrong. So I'm going to list all of those outcomes in the sample space. So I get the first question right. Second question right. Third question right. You see the pattern, I hope? How many different ways could we do this? Wrong, 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 right. Wrong, 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 wrong. This is art. I'm doing art class here. Teaching across the curriculum. Did I get them all? Did I skip one? Okay, I'm missing one somewhere. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I only have 9 W's. There we go. 10 possibilities for getting one question right. So if I ask you, find the probability of getting one question right, and 9 wrong, probability of getting 1 right. That's 10. There's 10 ways to do that. So I have to multiply 10 times. The probability of getting one question right is 0.25 raised to the first power times 0.75 raised to the 9th power. There was 1 right and 9 wrong. So I'm going to calculate that. 10 times 0.25 times 0.75 raised to the 9th power. .187. It's probably getting 2 questions right. Okay, that's way more complicated. Because then how many different ways can I get 2 questions right? Right, right, wrong, 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 right, wrong, right. Okay, that's going to be like 40 or something like that. 45? I don't know. There's a lot of ways to get 2 questions right. So we're going to list that method. How many possible ways could we get 2 questions right? So what I did right there, the probability, this counting, I listed the number of ways to get 1 question right, follows a combination. And the book lists it like this. It's on page 387. It's called a binomial coefficient. We're just going to make room here. So for the binomial coefficient, new notation. Okay, everything's going to be new today. N, K. It's not N divided by K, it's just written as NK, which is N factorial over K factorial times N minus K factorial. So I'm going to show it by hand, and we're going to do it on the calculator. So this is 10 right here. This is 10, 1. 10, 1. Should be equals to 10. Okay, well, let's figure out why that works. That's 10 factorial over 1 factorial. 1 factorial is just 1. Divided by 10 minus 1 is 9. 10 take away 1 is 9 factorial. 10 times 9. Okay, factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Nine factorial. 9 times 8. Alright, now I'm going to cancel. People call it cross canceling or whatever. 9 over 9, 8 over 8. Cross off 4s, 3s, 2s, and 1s. So what's left is 10. This is equals to 10. Alright. This is the same at the binomial coefficient. It's called a combination. So N C K. This is N C K. So if I ask you what is 10 C1, that is just 10. We just found it. So what I'm coming up with, this is only the number of ways to calculate how many different ways we can get 10 questions right. So the next question would be, what's 10C2? How many different ways can we get 2 questions right? So that'd be 10, 2, which is 10 factorial over 2 factorial times 8 factorial. I said 8, I didn't write 8. Okay, there we go. So the 10 factorial, I'll do it down here. Don't worry, we're getting somewhere. We're going to calculate this probability. All these 3 probabilities up here. So this is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. I'm going to write 8 factorial. 2 factorial is just 2 times 1. Alright, 8 factorials cancel. 10 times 9 divided by 2 is 45. 10C2 is 45. 10C1 is 10. 10C3. What's 10C3? Oh, I had it right. I guessed it earlier. It was like 45. 10C3 would be 3 factorial is 6. So I'd have to do 10 times 9 times 8 divided by 6. 10 times 9 times 8 divided by 6. 120. 10C3 is 120. Okay. That's showing the work, okay? We could do it on our calculator. On the calculator. So thank you for our TI calculator. We're going to go to Math. Go to PRB or PROB for probability. And NCR. Instead of NCK, it's NCR. So, calculator, they use R instead of K. Book uses K instead of R. They didn't talk to each other. I don't know why. Number 3 is NCR. So here's how you're going to enter it into the calculator. You're going to enter 10. Then go to Math PRB, number 3. NCR. And 3. Or, what are we doing? I want to do 10C1. I should get 10. 10. And this, stepping through those directions, page 388. So the calculator stuff is on page 388. They always show the TI-84 calculator stuff, page 388. So find n. So I hope you can be able to do these on the calculator. And we have to use this for the binomial distribution formula. So the first one, I counted the number of ways we could do that, which was 10. And I showed it, but there's 45, 120. It's going to get bigger and bigger and bigger. 10C4, 10C5. Huge numbers. There's a lot of ways that we could do this on the tree diagram. Alright, the formula goes like this. Okay, are you ready for the formula? Binomial probability, page 388. So, binomial probability formula, page 388. And I don't really like the notation, probably x equals k, and they use nk. I'm going to use nck, so you could write it probability x equals k. This is not division. This is just the NCR. This counts the number of ways. You'll learn about the NK in probably math analysis if you're in math analysis, or if you already took it. Probability of raised to the K. And sometimes here it would say Q. If you ever see Q, Q is 1 minus P. P is probability of success. Q is probability of failure. Or if we're going to do our formula, probability X equals K. N C K. It's the same thing times P raised to the K. So let's go through the formula. I told you that the previous page, and probability of getting 0 questions right. So it follows a binomial distribution. Probability X equals 0. I would do this on the Nearpod, but it takes a while. There's not enough room. Probability X equals 0 is 10C0. 10C0 is just 1. Probability of success is 0.25. 0.25 raised to the 0 power is 1. 1 minus 0.25 is 0.75. 10 minus 0 is 10. 10C0 is 1. 0.25 raised to the 0 is 1. So we got 0.75 raised to the 10th power, which I computed without using the formula. 0.75 raised to the 10th power is just 0.75 raised to the 10th power, which was 0.05. 5% chance of getting none of them right. So it follows the formula. So now that we know that, we can look at the binomial distribution table. Find the probability of getting 0 questions right. Well, we did it already. We found probability of 0 questions right was 0.05. Probability of getting 1 question right is, let's see here, .05. 0.056. Usually we go out 3 or 4 decimal places with this because it's a proportion probability. Find the probability of getting 1 question right. We just did that. I think it was 0.187. So what I want you to do is use the formula to get the probability of getting 2 questions right. Probability X equals 2. So see if you can use the formula. We just learned a new formula. See if you can do X equals 2. Come up with that probability. Just a sec, I have a student that's in the wrong place. Sonia, we're in 5th period right now. You got to go to 6th period. Go to your 5th period. Go to your 5th period class right now, Sonia.
Alright, bye.
Alright, thank you.
Mr. Silver,
Hey.
the P in the equation is probability of success?
Yeah, which is 0.25.
Okay.
Let's see if I could fit it in here. 10C2. That's an 8. Doesn't look like an 8. Just as bad. Okay. .281. Or closer to 2. Alright. 0.282. Okay. 28% chance of getting 2 questions right. That was pretty likely. Alright, that's the formula, okay? That's how to do it by hand. We don't always have to do everything by hand, but if you're taking an AP test and they say find the probability x equals 3, okay? You should write the formula and then do the rest on the calculator. Find the probability x equals 3 for this problem. Okay, we can do the formula, but there's a shortcut in the calculator. And like normal CDF, this is called a binomial PDF. So for binomial PDF, you're going to enter N, P, K. Or, in fact, X, whatever your X value is. So for 3, we're going to enter binomial PDF. N is 10. There are 10 questions. P is 0.25. X is 3. Okay, where do you find a binomial PDF? That is in second bars. Press second bars. Go to binomial PDF. we should get 0.25. Remember, that was pretty likely to get 3 questions right. Originally, we had 39% of our students got 2 questions right, and 22% of our students got 3 questions right. So we were pretty close with our simulation. We knew that probability of getting no questions right, 5% chance. We knew that getting 2 or 3 questions right was the most likely event to occur. Getting 10 questions right. Remember this one? This one was 0.1, 2, 3, 4, 5, 6. 0.009. That was 0.75 or 0.25 raised to the 10th power. So we want to find all these probabilities. Probability of 4, 5, 6, 7, 8, and 9. This is called a binomial probability distribution table. I can complete the table in my list. Okay, so this is a really cool shortcut for binomial probability distribution table. And it's not in the book. You're not going to find it online. This is only a Mr. Silva technique. Alright? So I got a secret. Alright? I'm going to share it with you on your calculator. Go to list. In list 1, enter 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to enter in list 1. We're going to enter all of our x values. So list 1 should look just like this. So x is list 1. Alright, that's list 1. In list 2, we're going to do a calculation in list 2. We're going to go L2, highlight L2, clear whatever's in list 2. So go L2, clear, and we're going to enter our function into list 2. So we're going to go binom, PDF, and we're going to enter n, which is 10. We're going to enter p, which is 0.25. And we're going to enter x, which is list 1. All the x values are in list 1. So this is the trick. L1. And then press enter, and we should see all these numbers go into the list. .25. What do we got after 0.25? 0.146. .058. So the probability of getting 5 questions right was 5%. 5% chance. That's still pretty likely. Anything that happens less than 5% of the time is unusual. So what's unusual for this case? Getting 6 questions right. is unusual. Getting 7 questions right is unusual. Is everybody seeing what I'm seeing? Instead of 3, 9, I rounded it to 4. Instead of 2, 9, I rounded it to 3. You guys good? Any questions on doing that? So I calculated all of those probabilities with a click of the button. Okay, it does them all for us. Oh, go ahead. I think, Giselle, you had a question?
For this tree, where do you find the button?
Okay, so highlight L2, and then you gotta go get it. You gotta go to second vars, and then go down to Binomial PDF, and then we fill it in at the bottom of the screen.
Okay.
So yeah, it'll pop up at the bottom, and then you enter 10.25 L1, and then press enter, and it should populate the list. You get all the numbers. Alright. PDF stands for Probability Distribution Function. You might have noticed that there was a CDF. And some people are like, okay, when do I use PDF and when do I use CDF? PDF is used when x equals a number. So if x equals 2 or x equals 3. If x is less than a number, less than or equal to a number, then we use CDF. So like if I do this is going to be 0.056. This one is probability of 0 plus probability of 1. This is the CDF function. Add up the totals. So we're going to do 0.056 plus 0.187. .243. Our calculator finds it really quickly by using Binomial CDF. And we would put in N, P, and then 1. So that would give me 0.243. So if you do Binomial CDF, it adds up all the probabilities that come before it. So to find, it's a cumulative distribution function. We did cumulative functions, or cumulative frequency distributions earlier this year. I think that was chapter 2 as well. So it just adds up all the previous values. But we could do that in the list as well. If I use my list, I'm going to go into list 3. I'm going to clear what's in list 3, and in L3 I'm going to do Binomial CDF. So I press enter on list 3 and go to second vars and go to Binomial CDF. 10, P is 0.25, X value is list 1. And they get up to 100% of your values. So I got 0.24, 0.52. 52% of the time, that's X is less than or equals to 2. So if you see this, probably X is less than or equals to 2. Is 0.52. And 3 is 0.77. Okay, so what does this mean? 77% of the time you'll get 3 or less questions right. 92% of the time you'll get 4 or less questions right. 0.92. So that's pretty good chances. Really good chances you're going to get 4 or less right. 100% of our students got 5 or less questions right. And that is 0.98. So I was pretty sure nobody's going to get a 6, 7, 8, or 9. I've gotten 6s before doing this, but never gotten a 9 or 8, 9, or a 10. Okay, the chances are so small, it's probably not going to happen. Like chance of winning the lottery. So small, it's probably not going to happen. Alright, if we could find all these values, we could also find the mean and standard deviation. So we just went through that, the shortcut. Okay, so for binomial distributions, we could transform it to a normal distribution. So this is something that's unique with discrete probability distribution functions. We could transform them and calculate means and standard deviation. So on page 391, if you follow along in your book, we got the mean and standard deviation for a binomial distribution. The mean is n times p. And they put mu x because sometimes we'd have 2 binomial variables. We're going to combine them. And standard deviation is square root of n times p times 1 minus p. So for our problem, we had 10 questions. The probability of getting a question right is 0.25. And that 0.25 is, there's 4 choices, one of them is correct. So it's a 1 out of 4 chance. That's where 0.25 comes from. So the average number of questions right is 2.5. Okay, and that makes a lot of sense because most people got a 2 or a 3. So we knew the mean is going to be between 2 and 3. Underneath the square root sign is the variance. So if you ever see or ask for variance, that is just n times p times 1 minus p. Without the square root sign, with the square root sign is standard deviation. So we got 10 times 0.25 times 0.75. And 0.25 is success. 0.75 is failure. Get a problem right, get a problem wrong. 10 times 0.25 times 0.75. So the variance is 1.875. And the standard deviation is 1.37. So I could use the binomial table to come up with some values using the CDF function on the probability of getting 9 or less questions right. I could also convert it. This is useful for when you have like a really large sample size, like if you have 200 people taking the quiz, right? Or 200 questions, multiple choice. Something crazy like that. We can calculate a normal distribution, put the mean in the middle, 2.5, with a standard deviation of 1.37. So one deviation is 3 point, if I did my math right, 2 deviations right over here. I gotta do that in my calculator. 5.24. So this is the 97th percentile. According to a binomial distribution, getting 5 or less questions right happens 98% of the time. According to a normal distribution, getting 5.24 questions right happens 97.5% of the time. This is 97.5 percentile about. It's actually 0.9772. If you look it up, 2 deviations. This is 0 standard deviations, 1 standard deviation, 2 standard deviations. Above average, what percentile is that? So we could say what score represents the 99th percentile. We could transform it to percentiles using mean and standard deviation. That's under the assumption that it satisfies a normal condition. And satisfying the conditions is n has to be greater than or equal to 10 times the sample size. Okay, so that sample size condition, if we sample without replacement, our sample size has to be large. But we'll get to that. We'll get to that idea tomorrow. So hopefully that covers. I hope that you get a chance to read some stuff, get into 6.3, at least just start it, do a Microsoft Word document, Office 365, start writing on your paper, do a few problems today. We got a few minutes left in class, so just try and start on a few of the problems from the homework. I cut down the homework a little bit. I answered the question previously. There's no midterm next week, so I'll let you focus on other classes, but there is a midterm assignment, which is due Friday. Did I make it due Thursday or Friday? 2:59 p.m. because I cannot access Canvas. I'm going to have to be grading Thursday. I think I made it Thursday, due Thursday. This homework 6.3 is going to be due Monday. Okay, so all we got is homework, and the Chapter 6 test is going to be, I'll make that due Wednesday or something like that. Okay, so I'll make that, I'll open that up probably tomorrow. Open up the Chapter 6 test. Alright? Alright, cool. I'm going to